Hello everyone, we're here with the portable power station, or PPS as I like to call it. So we have the power station here. Don't mind this, we're going to use this for something else. I haven't put it yet, but we have ports. The portable power station that we're building is purely made from taking parts from cars and electric appliances, which you can find anywhere. We take parts from those and integrate it into this one system, which then we can use it to power up, use it as a generator. And we'll do a video on that where we'll have the whole system set up and you can see it. But here we have these two ports. These are taken from a car, from a junkyard. We have the switch right here. This very simple switch. Now, of course, this switch we bought it, but a lot of time you have switches all around. You can use switches that you can find as long as it can support the 12 volt. It won't be an issue. So this or another switch could work, no problem. This is just to cut the power from the battery and the whole system, and then turn it on, off, on, just so that it's more easier. So we're gonna go inside the power station. Inside the power station, we have the battery. We have the setup as we have for the fuse terminal. This is our main 60 amp fuse, which will protect the overall system from the power coming from the battery. So that's connected there. Then we have a wire connecting back to our switch, and then another wire from the switch connecting to our fuse box here. Then from our fuse box, we have power from negative going to the negative terminal, positive going to the positive terminal, and then we have a series of wire. These wires, of course, are not used yet at the moment, but the wires that are going to be used is this, mainly. So this wire is here, that wire is there, and then we have our fuse right there. So the purpose of this video is, one, to give a small overview of the system, but also go over one of the functions which is working and we found success in. We have the wire from the negative terminal connecting to the negative terminal of this port, the car port. And then we have the positive terminal wire connecting to the positive terminal of the port. Now we'll do a quick test. So we have a 10 amp fuse just to protect it, and that should be enough. We're going to charge a phone. I will turn off the lights so that you could see. So we turn it on. We have power coming in. This power now is protected. What we will do is we will plug in our phone into it. So we have here, that is in. We go to our phone and we plug into our phone. Here, if you could show, we have power going into our phone. So the phone is charging. Of course, depending on the different wires you use, of course, this is a very bad wire. It's not as strong as the other wires I have. That's why it shows that this is charging, but it shows a 5-hour limit. That's because it's not a fast charging wire, while the battery still produces that sends in that 12 volt. The wire doesn't do the job of doing it properly because it's an older wire. It's weaker. However, with a stronger wire, which most modern wires are very strong, we could have more power coming in, and that could easily charge in the battery. But now, as we demonstrated, we have power coming in, the power is protected, and it's lighting up. Now we could give many different functions to these ports. We could plug in a wire that can connect different lights into the system, no problem. We could also attach in a DC, what's it called? Let me show you. and AC to AC power. Okay, we'll have the lights on, and then I'll show this to you. We'll have a DC, direct current to direct current adapter. This adapter could connect to a full wire that goes into LEDs. So it could be connected into this one we have in here, and we just plug it into the system somewhere, anywhere we want, and then plug in those LEDs, which can take in that direct current. And that's pretty much it for now. However, overall, we have the power we need in here, and that's what we needed for this test. Thank you so much.